All right, as I said, I am very excited for today. Today we are talking about 9.1c, and we are doing the Pythagorean theorem converse. Okay, so yesterday we talked about the Pythagorean theorem, and the Pythagorean theorem said that if we have a right triangle, then, I'll do it over here, a squared plus b squared is equal to c squared. Okay, so if we have a right triangle, then the sum of our squared legs is equal to the square of the hypotenuse. Now remember, we learned this way back in chapter 2 last semester, that whenever we hear the word converse, we're going to switch the if and the then parts of our statement. So our Pythagorean theorem converse says that if a squared plus b squared is equal to c squared, then we have a right triangle. All right, so we're going to take a look at some examples today where we are given all three side lengths, and we're going to determine whether these triangles are, in fact, right triangles. All right, so our first example today, we have a triangle that looks like this. And we have the lengths of 22, 14, and 26. Now, the hardest part of setting up these equations here, that a squared plus b squared equals c squared, is to determine which two sides are our legs and which side is our hypotenuse. Okay, what is going in for a and b and what is going in for our c? All right, so remember yesterday how we said that our hypotenuse is always going to be our longest side. So we take a look at the side lengths that we have and we look at our longest side, in this case that 26, and that is going to be our hypotenuse, that longest side. All right, so that's going to go in place of C. So I'm going to plug that in on the right side. We're going to say 26, and then we're going to square it. Set up that equal sign, and then add and square the other two sides, or our legs. So we have that 14, and we're going to square it, and add it to that other leg, 22, and we're also going to square it. All right, so just using our calculators or our big brains, we are going to figure out that 14 squared, or 14 times 14, gives us 196. And that 22 times 22, or 22 squared, gives us 484. And is that equal to that hypotenuse of 26 squared, or 26 times 26, of 676? Now, when we add together 196 and 484, we get 680. And we can see that 680 is not equal to 676. So this triangle is not a right triangle. I want you guys to go ahead and just draw an X there, so it tells me, no, this is not a right triangle. All right, let's do another one. This one, we have the lengths of 7, 8, and the square root of 113. Now with the last one, it was really easy to determine what our hypotenuse was, that 26, because we saw that 26 was greater than 22 and 14. But with this one, I don't know what the square root of 113 is off the top of my head. So we're going to use our handy dandy calculator, and we're just going to plug that in. All right, so I'm going to plug in the square root of 113, and we can get a decimal approximation for that. And it says that the decimal approximation is 10.6, which is greater than 7 and 8. So that is going to be our hypotenuse. Okay, So again, plugging it in the exact same way, we're going to put our hypotenuse on that right-hand side, the square root of 113 squared. And is that equal to our two legs, those other two side lengths of 7 squared and 8 squared? All right, so we're going to either use our calculators or our handy dandy brains to figure out that 7 squared, or 7 times 7, is 49. And that 8 squared, or 8 times 8, is 64. And we're going to figure out, is that equal to the square root of 113 squared? So we learned on Monday that the square roots cancel out our squares. And we can test this in the calculator as well. Okay, so if I do parentheses, square root of 113, close my parentheses, and then square it, we can see that they do in fact cancel out. We just get that 113. Okay, and then we add up 49 and 64, and we do get 113 is equal to 113. So this triangle is in fact a right triangle. I want you guys to go ahead and put a check mark next to that so you know, so I know that you know that this is in fact a right triangle. All right, looking at our next one here. We have the side lengths of 21.2, 11.4, and 23. All right, so no crazy square roots here. We can see that 23 is in fact our greatest side, making it our hypotenuse. So that's going to go on that right-hand side. So we have 23, and we're going to square it, and then set it equal to the sum of the squared sides of those legs. All right, so I'm going to take my first leg, 21.2, and square it, and then add it to my second leg of 11.4, also squared. All right, so we're either going to use our calculators or our big brains, and we're going to figure out that 21.2 times 21.2, or 21.2 squared, gives us 449.44. And that 11.4 times 11.4, or 11.4 squared, gives us 129.96. And that 23 squared gives us 529. When we add together 449.44 and 129.96, we get 579.4. And is that equal to 529? No, they are not. So I'm going to put an X right there, showing that these are not equal and that this is not a right triangle. All right, and then the last example of this type is going to be here, where we have the side lengths of 9, 15, and 3 root 34. Okay, so we have to decide which side is our longest side, that hypotenuse. So once again, I'm going to take a look at my calculator, and I'm going to type in 3 root 34 to get a decimal approximation to see if it is greater than 9 and 15, or if 15 is our hypotenuse. So the decimal approximation for this is 17.49. So that is greater than 15, and it is greater than 9. So that is going to be our hypotenuse. So we are going to plug that in on the right side here and square it. And we are going to set that equal to the square of our other two sides, or our legs. So we have 9 squared plus our other leg of 15, also squared. Again, using our calculators or our big brains, we are going to find out that 9 times 9, or 9 squared, gives us 81. And that 15 times 15, or 15 squared, gives us 225. And then this can get a little tricky. On Monday, we got the tools so that we could do our factor trees. We would multiply our two coefficients. 3 times 3 would give us 9. And then we would do the multiplication under the square root, that 34 times 34, and get the square root of 1,156, and then have to do our factor tree. Okay, but I am totally fine with problems like this if we want to take a peek at our calculators here and do parentheses. Then our problem here, so 3 root 34, close our parentheses, and then square it to get that 306. Okay? Then we go ahead and just do our addition. 81 plus 225 does in fact give us 306. And 306 is equal to 306, so I get a little check mark there saying, yes, this is a right triangle. All right, but the Pythagorean theorem converse goes even further than that, proving that we have right triangles here. Okay, so it also shows us some other little nifty tricks. So we just talked about if our a squared plus our b squared, I'm going to put a little box here. If a squared plus b squared is equal to c squared, we have a right triangle. We just talked about that. That is what the Pythagorean theorem converse says. However, we got two more that are super cool as well. We have if a squared plus b squared, ooh, it's a mystery. If a squared plus b squared is greater, if the sum of our squared legs here is greater than the square of our hypotenuse, then we have an acute triangle. And I'm sure we can guess what the third one is, but I'm going to go ahead and write it out. If a squared plus b squared if a squared plus b squared is less than c squared, then our triangle is obtuse. All right, so I have a couple examples for us to go ahead and look at these as well. All right, so our first example of this type to determine whether we have a right, acute, or obtuse triangle looks like this. We have the sides of 12, 6, and 14. Again, we're going to set these up exactly the same as we did for our last 4 examples. We're going to find our hypotenuse and put that on the right side. So our largest side, our hypotenuse, is that 14. Okay, so we're going to square it. But instead of writing an equal sign next to it, I'm actually going to write a box because we want to fill that in with either an equal sign, a greater than, or a less than. Okay, and then we're going to compare it to the sum of our squared legs here. So we take our 2 legs, 12 and 6, we add them together and square them. And then we use our calculators or our big brains to figure out that 12 times 12, or 12 squared, gives us 144. And that 6 squared, or 6 times 6, gives us 36. Now we still don't know if we're greater than, less than, or equal to, so I'm going to keep that box. And that 14 squared, or 14 times 14, gives us 196. Now we add everything together. 144 plus 36 gives us 180. And we're going to compare that finally to 196. And we can see that 180 is less than 196, making this an obtuse triangle. All right. Our next triangle looks like this. We have the side lengths of 2, 4, and the square root of 17. All right, we ran into that same problem where we don't know if the square root of 17 is greater than 4 or 2, so let's plug it into our calculator and let's find out. We might even be able to use our heads for this one because we know that 4 times 4, or 4 squared, is 16. So we know that the square root of 16 would give us 4, so the square root of 17 is probably going to be greater than 4, but there's no harm in checking. So the decimal approximation for the square root of 17 is 4.12, and so on. So it is greater than 4. Even though it still starts with a 4, it has all that decimal stuff after it that shows that it is greater than just 4. So that square root of 17 is our hypotenuse. I almost said hypothesis. So that's going to go on our right side. Square root of 17 squared. We're going to keep that box because we want to make a comparison to our 2 legs here. So we have the leg of 2, and we're going to square it and add it to our second leg of 4 and also square that. So 2 times 2, or 2 squared, gives us 4, plus 4 squared, or 4 times 4 gives us 16. And we're going to compare that. And remember, we learned on Monday that the square root and the square cancel out, so we are just left with that 17. Okay? So 4 plus 16 gives us 20. And comparing that to 17, we can see that 20 is greater than 17, so that makes it an acute triangle. All right, 2 more. Our next triangle looks like this. We have the side lengths of 3, 5, and 6. We can very easily see that 6 is our hypotenuse. That is our longest side, so that's going to go on our right side here. 6, and we're going to square it. And then we are going to compare that to the 2 legs. So we have that our leg of 3, and we're going to square it, plus our leg of 5, and we are also going to square that. So using our calculators or our big brains, 3 times 3, or 3 squared, gives us 9. 5 squared, or 5 times 5, gives us 25. And we are going to compare that to 6 squared, or 6 times 6, which is 36. 9 plus 25 gives us 34. And comparing that to 36, we can see that 34 is less than 36. So we once again have an obtuse triangle. All right, and then our last example for today, we have our last triangle that looks like this. And we have 3, 4, and the square root of 7. All right, so again, we're going to plug this into our calculator just to be sure, but we could probably do this one in our heads as well. We know that 3 times 3 gives us 9, so the square root of 9 is 3. And since 7 is less than 9, we know that this square root is going to be less than 3, so this is not going to be our hypotenuse. Okay, so let's make sure that we're getting a decimal approximation here. So we have the square root of 7, and that decimal approximation is 2.6. So it is less than 3, and it is not our hypotenuse. Making 4 our hypotenuse, so that is going to go on the right-hand side. And we are going to square it. And we are going to compare it to our 2 legs added together and squared. 3 squared and added to root 7, also squared. Using our big brains, 3 times 3, or 3 squared, gives us 9. And we learned on Monday that the square root and the square cancel out, so we are just left with that 7. Okay, and then 4 times 4 gives us 16. 9 plus 7 gives us 16, and comparing that to our answer of 16, we can see that 16 is in fact equal to 16, so this is a right triangle.